Okay, so I'm just in the beginning stages of getting somewhere with this project. This is a PDP-8 emulator done with a AVR X Mega processor. The obviously you can see that the processor is still on this breadboard behind it, but this initial board here is a test board just to test the display and the keyboard and all that. So the first thing that I have going on I want to go over is the interface. You can see that we have on the display a 00600. Everything's in octal on this. Instead of implementing a binary control panel, which would have taken up a lot more space, I wanted something compact. So I did a octal control panel, and on the left of the display, the 5 characters on the left is in this case, the program counter or the PC. The right, the 7300, is the instruction there. So the left is the address, the right is the data. Now you can see that there's a light above the PC4 key there. That is indicating what's on the display. If I hit the mem button, I can switch it to the memory view. So now it's showing you just actual memory. If I go to the ACC, this is the accumulator view, and then the 0 on the left display is the link. If the link were 1, that'd be a 1. So the SR, this is the switch register, and then MQ is part of that extended arithmetic thing. So CFG is not implemented yet, but it will be eventually. That'll let you configure various things about it. So I'm going to go back to the memory view and show that you can also do a previous or next to change what address you're working with. If I want to change some memory, I can just hit this data button here. Once you do that, it gets into an edit mode. You can see how it's blinking that 0, and now the keys become octal entry keys. The bottom you have 0 through 3 and then 4 through 7. So if I wanted to change this memory location 00000 octal into something different, I can just do 4444, and then voila, location 0 has been changed. So that's basically how easy the interface is. You know, I tried to come up with something that would let you control the machine like the original control panel would let you control the machine, but with a minimal number of buttons. So the PC, let's go back to that. It starts at 600 because I've got a test program loaded. The test program is a M4 Enigma cipher machine. So what it will try to do is, and it's got different modes. There's a teletype mode to it, and there's also just a control panel only mode, which is meant to be operated by the control panel. So in this case, I'm going to go to the switch register, and I'm going to enter a 1. And I've got my little table next to this. I don't know if you can read that, but a 1 is an A. Okay, and let me see if I can zoom in on this a little bit. So you can see at the top there it says that AA, and then it's got a little caret to BDZ. My eyes are getting terrible. GO, and then it's gonna. That's how this would normally encrypt using the current machine settings. So the output of this should be 2, 4, 32, 7, 17, all in octal. So I've gone ahead and entered the A, which is 1, into the switch register. Now if I go to the accumulator view and I go ahead and do start, you'll see the run light flash briefly, and you'll see that the result left in the accumulator is 2. That's our 2 from the result that it should be. The next one should be 4. The next one should be the 32, which is a Z. Next one should be the 7, which is a G. And then finally a 17, which should be O. So that's basically operating it like a Enigma cipher machine, control panel only. So there's other things you can do. Obviously, if I go to the memory view again, and I'm going to change this 4444 to a I think it was 7002. We'll see how my memory is here. Instruction. I think that's the rotate left instruction. Hopefully, I'm right about that. I'm going to go next, and I'm going to put a jump instruction here that says go back to 0. Okay, so I'm going to go to the accumulator, and it's got that 17 in it right now. I'm going to change that to just be 1. So it's just got 1 bit on. Then I'm going to go back to the PC, and I'm going to change that address to 00000 because that's what we want to run. Well, let's go step through this and see if it does what I hope it's going to do. Oh boy, that's probably the swap, maybe? I don't know. Yeah, it looks like it's doing the swap instruction. You can see it's swapping the upper and the lower 2. Let's go back to memory and address 0, and I'm going to change that to 7004. Oops, I hit the wrong button. data. Okay, now this is perplexing. Okay, so we got a bug here. Oh, I know what it is. I'm not leaving the edit view. Now I'm out of the edit view. Now it's a bug. Okay, so there we go. Okay, so I'm going to change this to 7004. Let's see if that's the right opcode. It might or might not be. I can't remember. So step. There we go. So, okay, so now you can see it's moving that bit left as I step. So 2 instructions, and it's going to keep doing that over and over and over again. Go ahead and do. Okay. So like if I go here to the PC, you can actually see it stepping between the 2 instructions over and over and over again. Changing that. So that's kind of, oh, I guess I got one more thing I can show, which is if I go to the PC and I'm going to go to a location in my program that is 00634. Now this is normally an instruction that tells it it's done. Go ahead and go to the area that halts so that the user can see what the results are in the accumulator. But I'm going to change this to be 5232, which basically tells it to run the Enigma code over and over and over again. I'm going to set the PC back to 600, and I'm going to start this. Okay, so basically now it's running the Enigma code in a loop where it's not stopping between characters. It's just running and running and running and running. So you can see that it's running. The one of the things that's taken a lot of time on this project is trying to get the instructions per second rate up. I think some of the original PDP-8s were sort of rated at 1/3 of MIPS, and I'm kind of up in that zone now, up in the 300K instructions per second. So so it took a little bit of time to work that out, but I think it's doing pretty good. So anyways, I just wanted to show where this project was. So take it easy.